I'd like to work through examples 2 and 3 from the worksheet that's entitled 1.3 Notes Worksheet Vector Arithmetic with Components. We did example 1 or number 1 in class, but I'd like to show you how to do 2 and 3. So that you can try these with me for extra practice. So first we're going to do number 2, which is the vector b minus the vector a. We'll do it in component form. So b is the vector 0, 4, and then we're going to subtract a, which is the vector 6, negative 3. So when subtracting vectors in component form, just subtract the corresponding components. So subtract the x component, so we'll have 0 minus 6 as our new x component, and then subtract the y components from each other. So we have 4 minus negative 3, which gives us the difference vector is going to be negative 6, comma 7. So that's how we do it in terms of numerically, in terms of the components. Let's do this subtraction graphically as well. So I'm first going to draw the vector b, which is 0, 4. So I'm going to draw that here, and I planned ahead a little bit because I know that I'm going to be subtracting the vector a, which is 6, negative 3 from that. So I'm going to start off to the right and down a little bit. So the vector b is 0, 4. So this is b. I'll put the component form on here. And then from that, we want to subtract a. So remember, when we're doing subtraction, we really want to think of this as b plus the negative a vector. So the negative a vector is the vector a, but going in the opposite direction. So negative a is the vector negative 6, positive 3. So when I'm doing subtraction or addition, I go along vector b, and then from there, so here I'm going along vector b, and then I'm going to start negative a from the terminal point or the head of vector b. So I'm going to draw the vector negative a, and that's going to be negative 6, 3. So I'm going to go left 6, 1, 2, 3, 4, 5, 6, and up 3. 1, 2, 3. And so this is our vector negative a. And then our difference vector, which is b minus a, I'm going to draw that from where we started. So that's here to where we ended. So where we started the b vector, the initial point, to the terminal point of a. And now I'm going to label this vector as b minus a. Let's check to make sure it's right. So we thought this was supposed to be negative 6, 7. So let's count. So 1, 2, 3, 4, 5, 6 to the left and 7 up. Let's see if that works. 1, 2, 3, 4, 5, 6, 7. So we did it correctly. All right, let's do number 3. So for number 3, we're going to have 2b minus a. So in terms of component forms, we're going to have 2 times the b vector, 0, 4. So this is scalar multiplication, minus the a vector, which is 6, negative 3. So I'm going to scale the b vector first. So this is going to become 2 times 0, which is 0, and 2 times 4, which is 8, minus the vector 6, negative 3. Now I'm going to subtract the corresponding components. So this is going to be 0 minus 6, the x components, and 8 minus negative 3. And that's going to be negative 6, comma 11 is our resultant vector. And now we're going to do this graphically. So I'm going to first draw 2b, and then from that we're going to actually add negative a. So that's how we're going to do subtraction, as adding the opposite vector. Okay, so 2b, I'm going to draw that. So 2b is 0, 8, so twice the length of b, but the same direction. So I'm going to start here, and I'm going to go up 8. So 1, 2, 4, 5, 6, 7, 8. And I will draw my vector in, 2b. And then I need to add to that the negative a vector. The negative a vector was negative 6, 3. So I'll do that now. So negative 6 is left 6, 1, 2, 3, 4, 5, 6, and up 3, 1, 2, 3. So this is our negative a vector. And then 2b minus a, so the resultant vector, is going to start where we started the b vector at its initial point, or at its tail, and it's going to go all the way up to where we ended the negative a vector. So this is 2b minus a, and let's make sure that we got it right. It's supposed to be it's supposed to be negative 6, 11. So let's see, 1, 2, 3, 4, 5, 6, and then up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that looks correct. The practice problems associated with these notes are good practice to visualize how to do vector operations geometrically. Those are problems 1 and 2. Problem 3 is doing that vector addition, subtraction, scalar multiplication in terms of components. So letter A, it says, 1A says, given that ABCD is a parallelogram, express each of the following in terms of vectors using the points of the parallelogram. So vector, this is actually vector CD. It's a little hard to see that it has a harpoon on top. So the vector CD, I'm going to draw that in. How can we represent that in terms of other vectors in our parallelogram? So remember, a vector, if we're doing a sum, it's where we start to where we end. So the vector CD, how else can we represent that? There's more than one possibility here. So since this is a parallelogram, CD is going to be the same as the vector BA. Remember, in a parallelogram, opposite sides are parallel and congruent. So if they're parallel, they're going to have the same direction. How about the magnitude of BC? Right, so the magnitude of BC, let me highlight BC. I need the length of that side of the parallelogram. So since it's a parallelogram, BC is congruent to the opposite side. So that would be congruent to AD. So I can write that as the magnitude of AD. You could also write it as the magnitude of DA. Opposite vectors will have the same magnitude. I'm going to erase these for a second. And we'll start our diagram again. So now I want to figure out what AD plus DC is. Okay, so AD, I'm going to draw that vector. So this is AD plus DC. So this is actually in the position that we'd want if we were adding those vectors. And so the sum vector is going to start where we started, which is at point A, and end where we ended, which is at point C. So the sum vector is this vector AC. All right, let's try that again. So I'm going to erase this. We'll use the same diagram. So now we're going to do DA plus DC. So I'm going to draw in the vector DA. And I'm going to draw in the vector DC. Okay, but now we see DC is not positioned where we want it to be positioned. We really want to start DC at point A. So we have to take this vector and move it over to start at point A. Since it's a parallelogram, we know that DC is equal to AB. So if we're adding DA plus DC, that's the same thing as DA plus AB. And so the resultant vector will start at D and end at B. So this sum is the vector DB. All right, erase one more time. Let's look at the next one. So we have DA minus CB. So I'm going to draw those vectors in. So DA is this vector. And minus CB. So CB is this vector. So they're actually the same vector. So if I'm subtracting a vector that's the same as another vector, we're going to get 0 as a vector. You need to put the 0 on top, right? You have to put, I'm sorry, the harpoon on top, because this is a vector. It's not a scalar. All right, what if we do AD minus AB? Remember, AD minus AB is the same thing as AD plus the opposite of AB. So let's clear my graph for a second. And now I'm going to draw in AD. So this is AD. And then the opposite of AB. So this would be AB. And this would be the opposite of AB. So that's negative AB. So I'm going to be taking AD and subtracting AB from it. So that would really, if I were to draw this, we'd be drawing it down here. But remember, vectors we can actually move to other locations as long as we're just translating them. So in order to really do this problem, I think a better way would be to say that AD is the same as BC. So AD is equal to BC. So now I'm drawing the blue vectors. And then from that, we're going to add negative AB, which is the same thing as adding negative CD. So this is negative AB. And then our resultant vector will be from where we started to where we ended, which is going to be connecting B to D. So this is the vector BD. And lastly, let me erase all the stuff that I wrote on here. We're going to try to actually add these 4 vectors. So if we're doing addition, we just continue to connect our vectors from head to tail. Okay, so we're going to start with the vector AB. So I'm going to draw that in, AB. To that, I'm going to add BC. So starting from B, going to C. Then we're going to add CD. And back to DA, which means we ended up where we started. So this is actually equal to the 0 vector again. All right, let's take a look at number 2. Vectors U and V are shown at the right. Use these vectors to sketch the following. So we want to do letter A. So that's 2U plus 3V. So 2U, I'm going to take U, and I'll just sketch it over here. So I can say U, U, U. So this is 3U. And to that, oh, I did it wrong. Sorry. Let's take that back. We only want 2U. So this is 2U plus 3V. So I'm going to take the V vector and make it 3 times as long and about the same angle. So something like that. 2U plus 3V. And then I will connect from where I started to where I finished. So it'll be something like this. 2U plus 3V. And these aren't exact because we're just approximating the scaling of the vectors. And let's do U minus 2V. So remember, U minus 2V is going to be U plus negative 2V. So I'm going to draw that here. So I'm going to have the U vector. Actually, maybe I'll draw it right on the diagram. So I have U, and to that I want to add negative 2V. So negative V goes in the opposite direction as V, but I need something twice as long. So this could be negative 2V. And then the difference vector, U minus 2V, would be from where we started to where we ended. And so this red vector would be U minus 2V. All right, number 3, or actually it's number 2. Number 2 of part 2 is we're going to do some vector operations with components. Okay, so we want to find the component forms of the resultant vectors from parts A and B. So we need 2U plus 3V. So that's 2 times the vector U, which is 4, 2, plus 3 times a vector v, which is 3, negative 3. When we do scalar multiplication, distribute this scalar, so 2 to the 4 and the 2, so that's going to become the vector 8, 4. Now distribute the 3 to each component of the second vector, so that's going to become 3 times 3 is 9, 3 times negative 3 is negative 9. And finally, to add the two vectors, add the x components and add the y components. So we have 8 plus 9 for the x component and 4 plus negative 9 for the y component, which is 17, negative 5. So that's 2u plus 3v. And the last problem, let's do u minus 2v. This is letter B. So the u vector is given as 4, 2. Minus 2 times the v vector is 3, negative 3. So we have 4, 2 minus, distribute the scalar, or the 2. So we have 2 times 3 is 6. 2 times negative 3 is negative 6. Now we're going to subtract the vectors. So subtract the x component, so 4 minus 6. And the y components, 2 minus negative 6. And this becomes negative 2, positive 8 is the vector u minus 2v.